So here's our Arduino. Good morning, everyone. So what we're going to do today is we'll try and get everyone on the same page with regards to Arduino. So bring out your Arduino and we'll play with it. First thing is you will notice that the Arduino has several pins. There are analog input pins and ground pins and power pins. So meaning meron siyang source. Merong 5 volts, merong 3.3 volts, merong ground, and may input ports and output ports for digital and analog. Okay. We power the Arduino using USB. Teka, parang ang bagal. And then go ahead and pwede mo niya lang ikabit yung USB cable niyo sa PC niyo. So the cable that they use is similar to what is used in old printers. And this will bring the signals, or rather the commands from the Arduino IDE and even the data out of the Arduino into your computer. Okay, so this is bidirectional. It also provides power. Go ahead and insert it in your USB. Okay. Now notice that there are surface-mounted LEDs. Actually, may nag-light up na isa, but pointer here. So you can see here, there are other LEDs, surface-mounted. They're very tiny. You can see them here in the Arduino. Okay. Indicators, and also you can control them as well. Okay. Now, go to your computer. So nakakabit na kunyari ang inyong computer now sa Arduino. So nakapower na siya. Now I'd like you to go to https://wawawa.arduino.cc. Okay. And go to software. Then download the IDE that is appropriate for your computer. All right. So it's also okay to, so here are your download options. So go ahead and choose kung ano man yung computer nyo. It can go for Mac, Windows, even Linux. Right. Now you can go and learn on your own several things about Arduino. Just click this getting started page and marami ka nang magagawa. Why? Wala akong, ayan, yan. Okay, yan na tayo. So, you can also get here the installations. Okay. Uso ngayon yung Arduino, maraming uso ngayon na web editor na lang, so you don't need to install. But if you want it to be nice and offline, you can download these. So for example, my computer is Windows. So pag na-install nyo na yan, you will see Arduino coming out in your computer, no? So now, i-click nyo na yung Arduino. Teka lang, ha? Nag-load doon sa kabilang screen. So punta lang ako dito. Ilipat ko lang dito sa screen na to. Okay, you see here the Arduino. Okay. Now, umpisa muna ay notice that marami actually siyang available na examples. So click File and study some of the examples. What we would like to do today would be itong basic blink. All right? Dito muna tayo sa blink, no? Because it will just make your surface-mounted LEDs blink. And it will also help us understand what's going on, no? Okay. So the Arduino integrated development environment system is similar to C, and it's nicely written in C. So you can see the C syntax here, like for comments, you have double slash. Okay. And here, don't need to write this, just load this and just study what happens. First part sets up the pins. The first argument tells kung ano yung pin na gagamitin for this. In this case, these are constants that are already built in the Arduino. And then the second argument tells you ano ba yan, input or output. Okay. And here, so these are set up. This is a routine for the setting up. And this next routine, void loop, this will go on and on until you turn off the Arduino, until you detach the Arduino from the computer. Okay? So what it does is it digital writes. So one of the pins is actually connected immediately to the LED built-in, no? And then it will set the LED to high, meaning it will turn on. And then there would be a 1,000 millisecond delay. Okay? This is in milliseconds. And then once again, it will write to the built-in LED pin, but now it will set it to low. So and then it repeats. So what you will have here is a blinking LED. Now, what you do is to run this sketch. First, it's important to check kung nasaan ba tayo naka-connect, no? So first, make sure that go to tools and make sure that you have chosen the COM port, communication port as a USB port where the Arduino is connected. Pag hindi ito properly selected, walang mangyayari. Okay, so automatically na-detect niya na sa computer ko nakakabit sa COM5 yung Arduino Uno. Please double check this if nothing happens. Okay, and also do select the proper Arduino that you are using. For those who already have an Arduino, automatically, sometimes nakikita niya na detect niya na, pero pag hindi or marami kayong Arduino nakakabit, please select the proper Arduino. In this case, what I'm using is an Arduino Uno. Now, so this is written in the computer. What needs to be done is this needs to be compiled and sent to the Arduino board. So, so dito sa tools, ayan. Sorry, dito pala, hindi pala dito. Dito sa mismong sketch, so ang tawag dito is a sketch. What we want to do is compile it first, no? So, teka, nasa na yung compile? Yon. So, go to sketch and click compile. So, this should be the practice kapag ikaw na gumagawa ng sarili mong program. You compile it first to see if there's any problem. So, if you click compile, you go down here and check if there are error messages. And it will tell you, and then it will give you advice kung what was the error about, okay? And then correct. So as you can see here, there's a progress bar here, and it says, okay, the sketch uses maximum. You see nothing, no problem here. So once you've compiled, it is now in a form that is understandable by the onboard computer of the Arduino. Now you can send this or upload this to the Arduino. So click this, okay? And then let's wait again. Let's take a look at the progress bar. It's going, and ikaw, bakit may mga ganyan na nakasulat? Wala naman ganyan. Okay, wait lang ah. Okay, teka, bakit global variables? Teka, hindi ko po alam kung bakit may ganito dito. Iba naman po ang ina-upload ko. Pero in this case, this is certainly not part of my program. Okay, however, normally, you would see some errors here. But if you see here, a very tiny here, but I hope you can see it. If it's done uploading, then it's okay. Now let's switch on over to the to the other a screen. Okay, so notice that now notice that the LED is blinking every 1 second because we turned it on and off. Okay, so you can go back to the program, play with the delays, no, and you can control the rate of the blinking. Done. Okay, so that would, for those who have not yet used their Arduino, this would be your first experience in it. So remember, please, the steps. Open a sketch, write a program. In this case, this is a built-in program. Make sure, always make sure that your COM port is attached to the or the COM port selected is the one attached to Arduino. Then, very important, compile first, check for errors, and then upload. So the compiling part is in the sketch, and there's an arrow there that says upload as well. Okay. Now let's go back to the program. So I'll share once again my screen. So pwede mo nang gamitin yung mga templates na ganito para palitan. The next sketch that we'd like to use is in examples, madalas natin magagamit to, back to basics, no? Is read analog voltage. Okay. So i-click natin yan, basahin natin yan. Click that, open that. Okay. So, essentially, this will convert analog signals coming in the analog pins of the Arduino. It will digitize it using its onboard analog to digital converter. Okay, and send it as an ASCII or value onto the serial monitor. Okay. For this, paglaruan naman natin ang ating breadboard. Okay, so regarding the rotation sensor, ito yung gagamitin natin, no? First, mag-setup tayo. Habang nandito tayo, i-explain ko lang yung bago bumalik ako doon sa screen. This sets up the rate of bit sending. So, hindi naman mabilis masyado yung ating signals. So, enough na to. 9,600 bits per second ang speed ng pag-send ng data to the serial port or the USB. This can be much higher if you have a faster application. Now, this is the initialization. You could also have put this, let's go to the loop. Now we declare an integer called sensor value, okay? And equate that to a function. So you see this pag orange, a built-in function, analog read. And this is a built-in constant A0. So this means the analog pin 0. Okay, so we are assigning A0 as for analog read. So we're going to read and put the value of whatever output that comes out of AO as sensor value. And then this next part converts that sensor value into voltage. As you know, if you recall, kung ilang bits, ano ba yung 1024? I think it's 2 raised to the 10, tama ba? Yeah, tama, 1024. So 2 raised to the 10. So ibig sabihin, natapunan yung aking our analog to digital converter is 10 bits, no? Including 0, kaya yung last number niya is 1024, no? So 1024 values including 0. So since the maximum output that the analog input pins of Arduino can read is 5 volts, if we divide that by 1023 values, then that is the value per bit or digital number. Okay, so to convert back to voltage, we just get the sensor value, which is a digital output, multiply it by this conversion factor 5 for every 5 volts, there are 1023 values, and then we can get the voltage. So essentially, this sketch converts your Arduino into a voltmeter. Okay. Now, from your stash, look for the potentiometer. Now, may potentiometer ko. It can look like this. Oh, wait, mas gusto ko yung may pin. Wait lang ah. Pick up your potentiometer. And the nice thing about this kind of potentiometer, you can put it in your breadboard. So pick up your cute little breadboard. Okay. So remember, please, in a breadboard like this, everything along, so in this case, everything along a column is connected. No, connected yan along column. Now, the thing about the potentiometer is it's actually an adjustable voltage divider. So this case, it's the maximum is 10 kilo ohms. These ends could either be put to 5 or ground, and they're interchangeable. And the middle part is the signal or the output part. This one divides the resistor into 2. So if you tear open a potentiometer, it's actually a coiled or torus-like wire wound in a coil, which is formed into a donut shape. And there's a part that, or rather, there's a conductor that touches the coil, and it is attached to the shaft or to this knob, no? And so as the knob touches part of the coil, parang nadidivide niya yung resistor dito at saka dito. Okay? So essentially, if you tap here, this is connected to 5 volts, this is connected to ground, and you tap here as the B out, you have an adjustable voltage divider. Now, go ahead and attach it to this way to your breadboard. Hindi, pag ganito na lang, patalikod para kita natin yung pin. So kahit saan dyan, okay lang. But, okay, saksak nyo dyan, like so, and we're good. Okay. Then pick up some cables. Now, good practice is to use color-coded cables. So for always, no? This is important because it allows you to debug properly your setup. So always use black for ground, red for power supply, and any color for output. So let's use yellow. So, okay. So again, ang importante lang, yung gitna, yun yung output. Masyadong bright ata to. Wait lang ah. Ayusin ko lang yung. Masyado naman. Yeah. Okay. So I'd like to connect this to this one. So this one naman dapat nakakonect sa ground. And yung gitna, kung saan man yung pin na nakakonect, yun yung sa login. So dun sa Arduino, hanapin yung nakasulat na 5 volts. Saan ba yun? Kita ba? Teka, ikutin ko lang. Medyo okay, sende. Alam ko na. And tasan lang ng brightness. Yes. Okay, yan. Okay. Kita ba yung part 2 na nakasulat 5 volts? Teka, wala bang reaction dyan? Hello? Feedback naman dyan. Can you hear me?
Yes, ma'am.
Nasusundan nyo ba?
Yes.
Okay. So hanapin nyo yung 5 volts. Okay? Doon nyo isaksak to. 5 volts. Okay, hanapin nyo yung ground. Doon nyo saksak to. Then, of course, kikita nyo yung A0. That's the analog in. Lalagay nyo dyan yung signal niya. Okay. Okay? So I'm attaching the red one to 5 volts. I'm attaching black one to ground. Pwede naman ito, dalawa yung pins for ground. So that's nice. Kung masyadong masikip, that can also be ground. Lastly, I'm attaching this to A0. Okay, right. And so, that's it. That's our voltage divider, no? And we can check kung gumagana nga yung voltage out through the Arduino sketch. So, let's go back. So, ito yung i-adjust natin. Dapat magbabago yung output kapag minumove natin yung shaft. Okay? Now, balik na tayo doon sa kabila. Stop share. Share screen ko dito. Okay. Share. Okay. Now, okay. Balik natin at try nating i-compile again. So essentially, it will read the output. Digital number ang lalabas, pero it will read niya. Tapos i-convert niya as voltage. I-convert niya na as a voltage. Analog signal ang pumapasok dito sa pin na to. That's why analog read. Tapos i-convert na to digital number, i-convert niya to voltage, and then people. All right. So you can compile first, see if there's no problem with the sketch. You can see the progress bar there. Okay naman po, wala naman daw po. So pwede nang i-upload. You can either upload here or upload here or upload here. Okay? So, ganun din. So, mukhang done uploading. Again, meron akong, I'm sorry, hindi ko alam kung bakit may lumalabas dito na ganito. So where is the output, guys? Mukhang done uploading, wala naman siyang sinabi na maliban dito, which is not found in our function anyway. So please ignore this. You might have, you won't find this perhaps in yours. Now let's go to tools, kasi doon natin makikita. Click tools and then click serial monitor. And here, out will come a table or a screen, and yun, perpetually looping doon sa pagbasa ng analog voltage. No? Now, I'm now moving the shaft or the knob of the Arduino. Okay? You can see, nagbabago yung voltage output. Okay. Yung tanong ko, may sumasabay ba sa akin sa pag-experiment? Hindi ko alam kung meron ba diyang sumasabay sa akin sa experiment. How are you doing? Hello?
Yes, ma'am.
Okay. Are you getting the same thing?
Opo.
Yes, ma'am.
Okay, good. All right. So now, nagmo-move na. So there you have it. You have a voltmeter. It's perpetually taking data. Okay? And anong pwede nating gawin? Well, what you can do is, for example, anong gusto nyo? Maglagay ng delay? Fine. Para hindi ganito kadami, right? We can just stop this. Okay. All right. Anong gusto natin gawin? I don't know, maybe lagyan natin ng delay para mas konti-konti lang. Okay, edit natin to. First time kong gagawin to. Ano daw? Delay. Ang gusto nating delay? 1,000? Sige, 5. By the way, itong mga functions na to, nasa help lang sila. Kung kunyari, naghahanap ka, meron pang ibang functions na ginagawa ito. So go ahead and look for that. May references dito. You can find it in references, tapos sasabihin doon kung ano yung, paano gamitin yung mga functions na to. Okay? So for our intents and purposes, this is enough. So, compile. So, anong mangyayari? May delay bago ilalabas niya. Kasi walang delay to eh. So, automatic, wala nakasulat na delay ngayon. So, pag walang delay, kung ano yung minimum time niya na tapos na, lulup uli siya. But now we will wait 1 second bago mag-output. So, okay. After sketching, time to upload. Upload na natin bagong program. And then, It's running now, but to see its progress, let's go to serial monitor again. Yan. And now, mas slow na siya. Okay? You can prolong you can even extend the delay further. Okay? Okay. So I'll stop this. So it's running in the background. But again, as I said, pwede tayong mag-check ng mga references. Ano kaya yung pinakamatagal na delay? Ano natin? So here, pag clinic ko yon, lalabas to, tapos lalabas yung mga special functions niya. Saan na yung delay yan? Delay, ito na ba yung delay? Functions for controlling Arduino modes and delay. Yun. Delay. So pag clinic nyo to, lalabas yung syntax. Alright. Bang sinabi kung ano yung maximum? Okay. More knowledgeable programmers usually avoid the use of delay for timing of events longer than tens of milliseconds unless the Arduino sketch is very simple. So this is better to be used pag matagal. Okay? So wala naman sinabing upper bound. So tagalan natin. Balik tayo dun sa sketch. Now, bakit gusto kong tagalan? Kasi yung susunod na experiment nyo, parang gano'n. Kailangan natin medyo mas matagal-tagal. Like say, 3 seconds. No? Yan. Compile ulit. Well, kung sure ka naman na wala masyadong aberya yan kasi minor lang yung kinorek mo, pwede mong i-upload agad yan. Kasi kukumpile na rin naman in the interim. Uploading. There. And again, check out the serial monitor to check the progress. Okay. 1,000, 2, 1,000, 3, 1,000. Oh, parang ganun, ano? So, 3 seconds na. Okay. Now you're set up for the experiment. The first experiment tackles the input-output curve. Sa paggawa ng input-output curve. Okay, isa-stop share ko na to. Nag-work ba yun sa inyo, guys? Feedback naman dyan. Hindi ko nakikita yung screen. Nakikita ko yung shared screen.
Yes, ma'am.
Happy?
Yes, ma'am.
Sana nag-i-enjoy kayo. Importante nag-i-enjoy kayo. Alright, balik tayo dito sa ating our iPad screen. Okay, guys. So the first task, ang objective ng first experiment actually is to be able to get an input-output curve which will convert this potentiometer into a rotation sensor. Okay. So online, makakahanap kayo ng mga templates for a protractor, right? The idea kasi is, total, narorotate naman natin tong potentiometer shaft. So, ibig sabihin, okay? So, ibig sabihin, kung naglagay tayo ng, for example, ito, no? Naglagay tayo ng stick dyan. For example, ito. I happen to have. It could be a fine stick. In this case, tinidor. But you can use a popsicle stick or whatever board you have. So for example, lagay natin dito. Hey, look. So pag umikot ito, mag-change yung voltage. But hey, di ba pwede natin gamitin to as an angle sensor? So, pwede natin siyang gawing digital protractor. Yeah? So, ang kailangan nating malaman ay, given a certain angle of rotation, ano yung voltage na ilalabas? Okay? And therefore, gagawa tayo ng input-output curve. So, ang gagawin nyo is, kung may printer kayo sa bahay, download yung template ng protractor, 0 to 360, ganon. So, template yan. Print it out, cut it out, put it on a stiff board, and figure out how to attach it properly dito sa may shaft, no? So you get a stick, can be a popsicle stick or any thin board that can fit this shaft, okay? And then, make sure na dun sa sagad na sagad niyang setting, yung 0, kunyari, naka-align yung 0 degrees ng potentiometer. And then, start tabulating. Kapag ganito yung angle, kunyari, 5 degrees, ano yung voltage na lumalabas ayon sa serial monitor. Then move the shaft again to 10 degrees, ano yung output. Again, on and on until masagad mo na yung rotation. Now, at 5 volts, it's not necessarily at 360 degrees kasi actually may limitation. Hindi naman full 360 yung ano, may konting limit dyan kasi hindi naman completely circular or completely touching yung torus dito sa loob. So hindi siya abot ng 360, but at least you can measure angles from 0 to more than 250 perhaps, okay? And tabulate that. So angle versus voltage. And there you have it. You have an input-output curve for your potentiometer para ma-convert mo siya as a digital protractor. Okay? Alam nyo ba guys, may mga motors, kasi maglalaro rin tayo with motors, na may built-in na potentiometer sa loob. So habang umiikot yung motor, umiikot siya dito nababasa ng potentiometer na umiikot siya. Na-measure niya yung angle or even yung number of rotations. So may mga motors na ganon that allows us to find out kung ano na yung angle, kung saan naka-rotate yung motor. Okay? So yon, may built-in potentiometer yung ibang motors. Okay? To allow for control and feedback. Na-imagine nyo na ba kung ano yung gagawin natin sa first experiment? We are going to convert this guy with the Arduino into a digital protractor. So once you have the input-output curve, you will use that as a calibration. You will use that, invert that, para the next time you use it, ilapat mo na yung angle, what the Arduino outputs is the actual angle. Question? Malinaw? Uy, yeah. Hello?
Yes, ma'am.
Okay. All right. Still in the topic of the first experiment. Kung titignan niyo yung ating first experiment, it's all about linear, nonlinear input-output curves and transient and steady-state response. Now, okay na to, no? Malinaw na yung gagawin natin for the first instructions. More detailed instructions will be given. Now, grab your stash and then look for this guy here. This is our LDR. Okay ba, may nakikitang ganito sa inyong stash? Yeah. Okay. All right. Now this guy here is a very nice, simple, cheap device, no? What it does is, this is normally, itong mukhang isaw dyan sa loob, that's a cadmium selenium compound. And selenium is actually sensitive to light, no? Mga Xerox machines actually, they have this element as well, no? And the thing is, the resistance of this compound changes with intensity of light. Now, again, pwede natin siyang i-configure as in a voltage divider setup. Let me explain. Teka ha. Okay pa tayo, guys? Teka lang. Kukunin lang ako. Notability. So, notability ko. ko na, ano ba? Okay. I want a new, ano, so, pagpalagay natin na meron tayong power supply and then a resistor R1. And then dito natin, tingnan natin ang mangyayari pag dito natin ikabit ang ating, okay, potentiometer. So, bali, ang potentiometer natin R2. Tapos meron tayong voltage source, no? Now, tandaan, ang V out, dito natin ito siya, is equal to R2 over R1 plus R2, V in. So, sorry, V in. Okay? Pag ganito yung configuration, kasi you might wonder, saan ba natin lalagay si resistor, potentiometer? Dito ba or dito? So first configuration, what if ilagay natin yung potentiometer dito sa baba bilang R2? Anong mangyayari? If R2 is large, anong mangyayari? If R2 is large, magkakaroon ng magiging insignificant si R1. So in this case, if R2 very much greater than R1, if R2 becomes very large, B out approximately B in, di ba? Kasi magiging halos R2 over R1. Okay. Pero if R2 is 0, pag naging 0 naman yung R2, well, B out is equal to 0. Paano ba gumana ang potentiometer? Ang ang LDR, no? Nagiging mataas ang resistance niya kapag walang ilaw. Pag mataas ang ilaw, bababa resistance niya. Marami siyang charge carriers. So, anong effect nun, guys? So, sa LDR natin, so you have a resistor which is affected by photons. No? If intensity is high, resistance is low. Okay? And vice versa. If intensity is low, resistance is high. Okay? Now, bagay ba siya pag ilalagay natin siya dito? Kasi ang lalabas dito, pag resistance is high, nangyayari ay V in will be equal to the maximum. Pero pag resistance is high kasi, ibig sabihin nun, yung intensity ay mababa. So parang baliktad doon sa nakikita natin. Na pag ideally, gusto sana natin, pag bright, mataas yung output voltage. No? So hindi ito yung configuration. So pag maliit yung resistance, ibig sabihin, mataas yung intensity. So, pero ang lalabas sa output natin, 0 or malapit sa 0. So ayaw natin yan. So let's think about what happens if we put the potentiometer, or rather the LDR, in R1. Now we are thinking that now it will become mas tama, no? So there's fixed resistor here. Okay, V out. So V out natin again is R2 over, ito naman, LDR na to, no? See what happens. Okay. So if RDL LDR, sorry, light dependent resistor is very much greater than R2, ano naman mangyayari dyan? Okay? Magiging something over a large number. Di ba? So in this case, B out would turn out small number. So it will approach a small number. Okay? Uy, mukhang okay yun ah. Look guys, kasi kung tumataas yung resistance, bumababa yung intensity. So kung baga yung trend nung B out natin is tama doon sa na-expect nating trend dun sa intensity. So what about our LDR very much greater than, or very much less than R2? So in this case, halos zero na siya or masyadong mataas yung R2. So it's becoming R2 over R2, which means B out will approach B in. Okay, the maximum. And a low LDR is when you have high intensity. And so we think that that's a good idea. So what we do is ganito. Kunti na lang gagawin natin doon sa setup natin. Instead, di ba nakalagay na yung potentiometer natin? So yung potentiometer natin, imbis na yung tatlong legs niya, di ba? Yan, ganyan, yung potentiometer natin. To. Pwedeng kabit na lang natin dito at saka dito. And, di ba, normally ito yung 5 volts and ground, no? Ito yung signal. Pag hindi natin ginamit to, instead, nag-connect tayo dito at saka dito sa dulo, ay resistor na siya na 10 kilo ohm. Okay? So, hindi na natin siya kailangang galawin. So, parang meron tayong 10 kilo ohm resistor. Of course, we can also adjust this kung ano pa. And then, let's put the an LDR here. Shall we? Okay, back to the screen. Questions? Okay pa tayo dyan, guys. So, share ko naman ngayon again yung video. Share. Okay. Ay, galaw na naman yung aking camera. Okay, yan. Okay. So, sabi ko doon, ano yung LDR? So, LDR, ano siya ha, bipolar siya. Ibig sabihin meron siyang mental disorder. Joke. Hindi. Ibig sabihin, pwedeng siyang baliktaran. Okay? Alright, wait lang. Autofocus yan. Alright. So, aalisin ko to, guys. Aalisin ko to. This is analog A0 doon sa signal natin, right? So, ito namang 5 volts. Aalisin ko din. Yeah. Remember, ito pwede nating, ay, kita. Remember, ito pwedeng ating 10 kilo ohm resistor. Okay? So, kakabit ko, siya si R2. So, yung itong paan yan na to, kakabit ko dun sa LDR. So, naka-join sila dun sa isang leg niya, no? You see that? And then yung 5 volts, dito ko ilalagay kay LDR. Okay. Then, yung signal, dito sa pagitan nilang dalawa. Yeah. Okay. So, wala nang use tong pag-turn ng bulb kasi hindi naman tayo nagtatap doon sa gitna nito. Instead, we tapped doon sa Arduino sa potentiometer doon sa dulo-dulo niya. So, it's a fixed 10 kilo ohm resistor. Are you with me? Okay pa tayo, guys? Uy,
Yes,
hello?
ma'am. Yes,
Okay.
Mama.
Okay. All right. So let's compile again. Let's see what happens. Then okay. Tatakpan. Okay. Ang gagawin natin ay tignan nyo yung serial monitor now and takpan nyo yung ano. So right now, it's exposed to my window. So medyo mataas yung voltage niya. Makes sense, no? If lumalabas ay mababa. So, wait. So, I'll cover it with my hand. So, umabot ako ng 2, 3, 2, 2, 4, 9, 2, 4, 1, 2, 2, 8. Hindi siya masyadong bumababa. Okay? Alright. Oh, I thought of something. Fix na kasi yung resistor, ano? What if ilagay natin itong ground dun sa gitna so ma-adjust natin yung range ng LDR natin. So, kasi ang lumalabas sa akin is hindi siya bumababa malapit sa zero. The lowest value, if I cover this, is 2, 2, 2. Not nice because I am not able to explore the full range of the the LDR. So, I'm thinking, itong ground, imbis na ikakabit ko dito sa dulo nitong potentiometer, kabit ko dun sa gitna. And therefore, para akong may adjustable resistor. Tapos pwede nating i-check kung pwede pang bumaba at tumaas. Bale, yung range, humaba yung range ng LTR natin. So I'm gonna attach the ground to the middle pin of the potentiometer such that it behaves like an adjustable resistor. Okay? Okay. Now, I'm gonna adjust this. Tingnan ko kung bababa pa. Ayan, bumaba ka. Okay, sige. I'm gonna adjust this lower. Yeah. Adjust this lower. Yeah, zero na. Dulo na ba yan? Kunti lang. Yeah. Okay. Okay. Nakadulo. Naka-zero. Pwede rin pala. So in this case, parang zero na lang. Essentially, pwedeng diniretso na lang natin sana yung LDR. But that's fine. We just want some finer adjustment. You can adjust this a bit para may konting bias. Tiny resistor. Okay? Okay, there. Yan. Okay. So in this case, halos parang ang ginawa ko wala na itong voltage divider kasi pag gumaganda yung output niya kapag medyo dulo na siya. But kumusta naman yung output? Sige, taas pa natin ng konti kasi this kind of time masyado namang baba naman. Wait lang. 5 volts ba siya? 5 volts please. Pagdating sa dulo, ano nangyari? Maabot lang siya ng 445. Okay, what if takpan ko to? 271, 228. Can it go lower? Ayan, now it can go lower. Pag na-adjust ko to. 30. Okay. So in this case, medyo bias lang talaga siya. Okay. Hindi nag-i-increase yung contrast, nag-i-increase lang yung, or nagmo-move lang yung range. Okay. What am I talking about? Let me now share itong screen ko. service. Again ha, you can use the middle pin. So ngayon, again ha, please I note that I put the ground doon sa middle pin so that I can play around with changing the resistor, changing the resistance and seeing ano yung magandang value ng resistance na makapag expand or stretch ng range ng ating output. I want to share my screen and I'll show you another trick. Okay. Okay. So, ngayon, ito siya, no? Ito yun. Do you see my... Teka. Okay. Balik tayo sa Zoom dito sa kabila. Okay. Kikita niya yung ano ko, no? Serial monitor. And now, right now, what I'm doing is I'm closing the LDR with my finger. And ito yung pinaka-lowest voltage value niya. It's not going to zero, but that's all right. Pero pag release ko siya and it's exposed to the window light, it's going that way. Okay. So parang yung range na mga around 2 to 3.7. That's fine. That's fine. Now, bilisan natin kasi medyo mabagal to, no? It's at 3,000. So alisin natin yung delay. What happens if we remove this delay? No? Okay. And then, essentially, yan lang yun, ano? Compile lang natin. Compiling sketch. Ito, diretso na natin kasi sure tayo, hindi naman erroneous yun, no? Please ignore. Nakasulat dyan. And then, serial monitor again. And as you can see, mas mabilis yung output niya. But what I want to show you is something more interesting, ano? Go ahead and close the serial monitor. So, close yung serial monitor. This won't work if you don't close the serial monitor window, okay? Go to Tools, and now go to Serial Plotter. Okay, what you see now is real time kung anong nangyayari. So if I close this, oh, di ba? You see that the LDR is reacting. And now I open it again. And now I covered it with my finger. Now I open it again. Are you seeing the same thing? So again, you can do this by, now I'm waving my hand in front of it. So what we need this for, you see, guys, so this is in milliseconds, if I'm not mistaken. So lumalabas ito. Ito yung not milliseconds, but this is not milliseconds, by the way. This actually is index. So kung pang ilang out, this is not milliseconds, mind you. Dito milliseconds. All right. Now, di ba sabi ko sa inyo, if you could kindly please install a strobe app. Kasi tignan natin na mangyayari kapag nag-flash tayo ng strobe app sa LDR natin. Wala mo na ha. Stop share muna. Let me show you the setup again. Share screen. Share screen. Screen. Start broadcast. So I have this app, strobe light. Okay. If you click that, right? Nice thing is you can change the speed, no? You can change the speed of the strobe. You can set kung may music ka sa phone mo, it will strobe to that music. But if you click light, you can see it's flashing now, and that's 19. Ay, sorry. Kita ba? Hindi. Masyadong mabagal yung refresh rate ni Zoom or okay? But actually it's flashing quite quickly. Okay? Hindi kita, no? Kasi mabagal na yung so I'll stop sharing this. But now the thing is, isa-shine ko to doon kay LDR. All right? Okay? hindi kita na nagsustrobe dahil mabagal pero nagsustrobe yan. So for example, this is at 36 hertz strobing. Okay? This is 21 hertz. This is 9 hertz. Okay? Hindi strobe siya. Okay. I'll stop sharing this screen, but remember please that a strobe light is being pointed at the camera. Then I'll share this one. And do you see that? Do you see it? Diba? Yung output ng LDR is like that. Okay. And I'll slow it down some more. You can see nag-slow down din siya, right? Okay. And here's the interesting thing. This is, teka, paano ba ito stop? Okay. What happens if I disconnect this right away? Pwede ba paano ba stop? But technically, what you see now is what we need to know, which is yung temporal response. Naalala niyo yung sabi ko dun sa first order, guys. Teka, stop muna. Stop natin. Stop. Okay. Yan. Stop na yung probe. Okay. Babalik ako doon sa serial monitor. Serial platter yun, ano? Serial monitor. Sige. Tapos, ulitin ko lang yung strobe. Na. Yeah. Strobe. Okay, walang delay to, but as you can see, parang tumitigil siya, right? Okay? I mean, bumababa, umakyat, bumababa, umakyat. I think this is the slowest I can go. No, 3 hertz. Okay, you can see here may delay na yan. Okay. Now, stop ko muna. And then it will remain constant. Will just fluctuate between 3.79 and 380. All right. Now, what we saw there would be actually gusto time constant. That gradual approach to the final value is what we really need to know. What is the time constant? That's the second part of the first experiment. So, kailangan natin yung actual time value. Kasi dun sa serial monitor, di naman kita yung actual time. Ang nakasulat dun sa x-axis ay index. And therefore, kailangan nating somehow maisulat yung timestamp. Okay? So how do you write the timestamp in the serial monitor? The thing is kasi, ganito yung gagawin natin, guys. Once you are able to get the serial monitor, ang gagawin natin ay pag hinugot nyo si Arduino, this will stop. I don't know if there's a safer way of stopping this, but if you power off the Arduino by removing the USB, just like what I did now, what you have would be, if you scroll the serial monitor, you see the historical values of the output, okay, in time. However, there is no timestamp. This cannot be saved directly. Instead, what you do is you crop out a certain portion and then you copy that. You can Control C to copy this and then Control B in your Excel sheet. So ganun ang way of extracting the data. All right. Now, but this doesn't have a timestamp. So what we do is let's put a timestamp. Now I have a sketch here. Recent. Okay. And this naman is hindi, dito. Sorry. Where is my sketch with the timestamp? No. Saan na yun? Lang guys Ito. Baka ito. Yeah. Okay. Okay. Now observe this sketch. What we want is to be able to get a timestamp so that we can use that for our experiments. So what I do first is I declare an unsigned long variable called time, and it's a reserved variable time. You just need to call it. And then this is similar to what we got, but now just before I read, I will ask that the timestamp be obtained by calling this function millisecond. Okay, what does millisecond do? Hanapin natin si millis. Hindi yan. Hanapin natin yung sa reference. Dito. Ulit. Sorry about that. Help. Ito yung ibig ko sabihin. In reference, meron siyang function dito na ang pangalan ay millis. Ano ginagawa niya? So if you click that, millis returns the number of milliseconds passed since the Arduino board began running the current program. This number will overflow or go back to zero after approximately 50 days. So ang unit niya ay milliseconds. Okay? Since the Arduino began running the current program. So okay lang kasi pwede natin tanggalin yung bias. Nice thing about this reference is you have an example how to use it. That's why I declare an unsigned long and then I called it. Okay? And I will assign to this variable the milliseconds, and then pwede kong i-display din. Okay? So let's do that. So back to the Arduino sketch. Again, we're doing this because we need to have a timestamp. Let's assign an unsigned long variable called time. And then once again, set up the baud rate. Assign the analog read, sorry, hindi pala. Ito na pala. Nag-read na tayo, and right after reading, we take the time. No? We take the time. So naka-save na sa time yung milliseconds since the Arduino started. And then convert once again, print the time, and put a comma and print the voltage. Okay. Tingnan natin, see what happens. So I'm gonna attach the Arduino again to the USB port. Making sure that it's connected. Yeah, okay. And verify first the sketch. And upload the sketch. And then let's take a look. It's running now. And then let's take a look at the serial plot, serial monitor. Ay, joke. Hindi naman sa serial monitor. Wait. I'm sorry. Merong error. Sorry. Hindi ko napansin. Teka lang po. Meron palang error. Tignan nyo, may pula dyan. Hindi pa siya done uploading. Uploading to I/O board. Sorry. Yun ko po. Ang daming ang daming error. Okay. All right, there's an error here. Sorry. Ito, hindi ko maintindihan tong error na to. Nasa get tools. Okay, there has been an error. There's a problem uploading. I'm sorry. Maybe detach the board this way again. Maybe close this sketch. I don't know how to properly close this, but let me close this first. Open it again where no. Maybe run Arduino again. I don't know how to. Sorry about that, guys. Probably have to run Arduino again. Ano naman dapat error doon? Hindi kailangan ko ng milis. Okay. Okay, let's see if it works again. Some sketch is voltage in a separated value format. Okay. The only thing we added was this, and then displaying time, comma, and the voltage. Now let's see if it works. Woo. Okay. Check first. Is the board connected, right? Okay. File, see if it runs. Cross fingers, ano, walang error. Done compiling. Okay. No error there. And then let's upload. Either this arrow or this upload here. Fingers crossed. Wait, what's this? Okay, it's still okay because it's done uploading, I hope. Let's see the serial monitor. Ayun, yeah, now it's better. Okay. Now guys, ang gagawin natin, I have 7 minutes left. Ito, I don't know how to stop it. So the bad practice is just hugutin from USB. Okay, go back to the very first part. Skip the first one. For some reason, ang nangyayari is there's some error pag hindi sinama mo in the first. So I'm going to select that and let's select a few values, shall we? Okay, yan. Then I'm gonna Control C. I'm gonna open an Excel sheet. And then let's see if we can, not sure, but worth a try. Ayaw. Hindi lumabas yung kama. There must be a better way. Let's save this as a notepad. Sorry, hindi yata pwedeng diretso sa ano. So this is a bit circuitous spot. Bear with me. So notepad, please. Notepad. Okay. Save muna natin sa notepad. Save as. Kindly save this as a CSV, comma separated value. So okay naman. Test CSV. Okay, stop na lang para mabilis. Save. Okay. And now we can try and open it in Excel. Browse the desktop and select a CSV file. It's there. That's our test. Okay. Now, that's right. Kasi comma separated values. So nakita niya na the tab is separated by comma. Now, we can start plotting this. Usually you plot, right? Insert chart. There you go. And that's it. And this is in time. And so, if we did the strobe, makikita natin milliseconds. Tapos, makikita natin kung saan siya umakyat. Mabibilang natin yung milliseconds kung saan siya nag 63% ng final value niya. Right? And hindi siya index. This is in actual milliseconds. So, you can have units of milliseconds talaga in the time constant. Malinaw ba? So 11:27, we're nearly done. So please do play with your Arduino. Medyo circuitous yung pagkuha ng data. However, it's the fastest way to do it so far. Okay? Questions? I'm done. Stop share. I hope you were able to play with your own Arduino. Have you? Kumusta ba dyan?
Hello po.
Yep.
Saan po ba naka-upload yung recordings?
Ay, hindi ko pa
Ay,
na-upload.
hindi pa.
Sige.
Ay,
Sorry.
akala ko ako lang. Sige po.
Hindi, sorry. May miya ko pa. Hindi naka-upload yung recordings pa. But yeah. Hopefully within the day, ma-upload ko. Maalala ko
Okay,
ma-upload.
thank you
Sorry
po.
about that. Other questions? May napagana ba dyan? Kayo ba inapagana niya rin?
Yes, ma'am.
Okay, good to know. Okay, that's it. So, if you have questions, I'm available during Friday, so you can chat and ask for help, and we can look at your setup if it needs debugging. Okay, that's it for today. Okay, if there are no more questions, thank you for your time. I'll see you asynchronously next week. Bye.
Thank you, ma'am.
Thank you po.
See ya.
Thank you, ma'am.
Thanks po, ma'am.